Moving on, this is somewhat unrelated to what you would have learnt in your previous section on quantum physics. Which, the previous section was mostly about atoms, oscillators, average energy and all that. So this one is a little, let's say, a little unrelated to that. But again, it broadly falls under the topic quantum. So what it says is angular momentum is quantized. Now, before we go into the technicalities of this statement and what it means, let's look at what angular momentum is. First of all, what is momentum? Momentum of a body is the product of its mass and velocity, m times v. And angular momentum is rmv, where r is the radius of the orbit in which the object is rotating. So we assume that whatever object we are looking at is rotating in a circular orbit of radius r. Then the angular momentum is given by the expression m times v times r. And now mass, velocity, radius, each of these quantities individually, they are continuous, meaning they can take any value. They are not discrete quantities. For example, the mass of a body can be 21.125. It's not like 21, 22, 23. It's not a discrete line. And the same applies for velocity as well as radius. But what this hypothesis of de Broglie states is that the angular momentum, which is the product of all these three quantities, is quantized, meaning it can only take specific values. And what are these values? They are integral multiples of something called h cross. MVR equals n times h cross, where n is 1, 2, 3 and so on. So how did he arrive at this equation and what is h cross? We will see now. So let's assume this is, you're looking at the structure of an atom. This is your nucleus and this is the orbit in which your electrons are revolving. This is the orbit for one particular electron. Now it was experimentally determined that the electrons, they move in these kind of orbits. They don't move in strict circles. They move in these kind of paths where you have these sharp points called nodes. This is a node, this is a node, this is a node, and these bent areas called antinodes. So they are moving, they are revolving around the nucleus. So in that sense it is circular motion. But the exact path is not a circular. It consists of these ups and downs, let's say, which are called nodes and antinodes. So it can be 2 nodes, 2 antinodes, 3, 4 and so on and so forth. So here n represents the number of nodes or antinodes in the path taken by the electron. So now de Broglie experimentally determined that the length of this path taken, consisting of nodes and antinodes, is actually equal to the perimeter of the circle. If it was revolving in a straight circle, whatever perimeter it would have had, that's the same length taken by this path also. It's only the shape that differs. This was experimentally determined. So what did he find out? 2 pi r, which is the perimeter of the circle, the circular orbit, is equal to n times lambda. So lambda, as we all know, is the wavelength, and that is equal to the distance between 2 consecutive nodes or 2 consecutive antinodes. So if I take this circle, this proper circular path, and if I say its perimeter is 2 pi r, and then I take this orbit which the electron is moving in, and let's say the electron has a wavelength of lambda and it is moving in this orbit which has 3 nodes, 3 antinodes, then 3 times lambda will be equal to 2 pi r. This was determined experimentally. So, based on this, you keep r alone on the left hand side and bring everything to the right. You get n r equals n lambda by 2 pi, which is nh by 2 pi p. Where did this come from? We just saw that lambda equals h by p. So n lambda by 2 pi is the same as n by 2 pi h by p, which is again n by 2 pi h by mv, because p equals mv. So now this h by 2 pi is a constant, because h, 2 pi are all constants. So we denote that as h cross. So basically your r equals n h cross by mv, or you take mv over here, mvr equals nh cross, meaning your mvr, that is your angular momentum, is equal to n times a constant. So it can only be h cross 2, h cross 3, h cross and so on are the only values your angular momentum can take. Now it might seem like a very insignificant observation right now, but we'll be seeing some applications of this deduction in the future lessons. But for now, all you need to know is the angular momentum of an electron moving in a circular orbit is quantized, and the values it can take are n times h cross, where h cross is nothing but Planck's constant divided by 2 pi, and n is the number of nodes or antinodes present in the orbit of that electron.